And I am the only one and only, Mr. Newbold. Welcome back to Graphing Rational Expressions, and with your host, Mr. Newbold. And where we want to jump over to is looking at the ones specifically with holes in them, and that's x minus 2 over x squared minus 4, which is problem number 3. And so the first thing we want to do there is going to put it in simplest form. And so we're going to jump over to here, and we're going to go ahead and set this up with factoring. And so what does x squared minus 4 factor into? Well, x squared minus 4 factors into x minus 2 as well as x plus 2. Excellent. Okay, and so then simplest form would be to cancel out the x minus 2's. So we're going to go ahead and do that in a gentle lining motion like that. But we still have to actually use the x minus 2 for something. So when it cancels off, we do get, let's see here, 1, and then divided by, right? So we get 1 divided by just x plus 2 is what remains. And so that's going to be the equation that we use for some of the rest of it, for most of it actually. Okay, and so let's see here. There we go, 1 over x plus 2. In fact, maybe we'll grab this here like that and copy and then delete it, and then we'll paste it. There we go. There we go. So 1 over x minus 2 is simplest form because the, or x plus 2, because the x minus 2's do cancel. Okay. Now, when we jump to, before we forget, the holes there, so x minus 2 is our hole. And so the reason why it's our hole is because it's a place on the graph that's undefined, that's not the asymptote. That's not the asymptote. The asymptote's what's left on the bottom. So we're going to go, and so what makes x minus 2, what makes that a 0? Or we can even set it equal to 0. So we're going to go down here to our hole. We're going to go x minus 2 equals 0. And so what makes minus 2 0? Well, a positive 2. So we're going to say that x equals 2 is our hole. Sweet. So there's our hole there. Excelente. And then there we go, there's our hole. Now our vertical asymptote is the other part here. And so x plus 2. So what makes that undefined? Down here, the simplest form. And so what makes that undefined? We could set it equal to 0 if we wanted to. That would help us out there. So we'll go x plus 2 equals 0. And so we minus that, we're going to go ahead and minus 2 to both sides. Minus 2 to both sides there. And so when we minus 2 to both sides, the 2's go away on this side, leaving us with just x is equal to negative 2. Okay, so we'll get this out of the way there. We're going to go x equals negative 2. There we go. Whoa, what happened there? Going to cut that and go back. Whoa, don't know what happened there. There we go. Okay, so x equals negative 2 is our vertical asymptote. So let's go ahead and make our vertical asymptote there at x equals negative 2. So that's right here at x equals negative 2. Excellent. There we go. Because it's become simplified, and so we can use that easily for our vertical and horizontal asymptote. Let's go back to the original there. So it looks like there's x to the first power is what we have there, right? X to the first power. There we go. And so since x to the first power is less than x squared, this is for a horizontal asymptote now. And so what we're going to say there is since x to the first power, since first power is less than x squared, do you remember? Then we're going to say we have a horizontal asymptote at y equal to 0. So then we're going to go ahead there with our asymptote and say that y is equal to 0. So there's our asymptotes there. And then we know we have a hole at x equals 2, so that's going to be here somewhere. But we're still not sure. We need to graph it first, and then we can kind of put that in there. Oops, right here. Okay, so now we need our x-intercept and our y-intercept. Excellent. So our x-intercept, what we want to do there is take the simplest form, and we want to go ahead and set it equal to 0. right? Set it equal to 0. So here we go. There's our simplest form there. Group that together. So we're going to set that. We're going to set y equal to 0 for the x-intercept. So we're going to say 0 is. Whoa. So we're going to say that 0 is equal to. Right there. So instead of being y, we put 0 there. Okay, now we're going to solve for x. So the tricky part there is that, well, we already know actually where the x-intercept is. I mean the the horizontal asymptote is, and so usually we have x on top to solve for x. But it turns out that when we go ahead and x plus 2 to both sides of our equation there, it's just going to get rid of it. And so that's another one that's kind of weird, because now we can't really solve for x on this, can we? Because when we multiply it to both sides, what's going to happen there is we're going to have the x plus 2's cancel, leaving us with 1 on this side. And then x plus 2 times 0 is just going to be 0. So we're actually going to end up with just 0 equaling 1. And 0 equaling 1, that's kind of weird. Yeah, that's not even going to make sense to us. So 0 doesn't equal 1, and so that means basically that the x-intercept, there's going to be none. Yeah, N-O-N-E. No x-intercept there, just none. And the reason why is our asymptote in this case. Cool. Now the y-intercept, we can find that one by setting x equal to 0. So we'll grab this one right here like that. There we go. And so we're going to go ahead and set that. So we're going to go there. We're going to go y is equal to, so y is equal to that. And then we're going to go ahead and change the x and make it a 0. And so 1 over 0 plus 2, well 0 plus 2 is just 2, so we get y is equal to a half. So at x equals 0, so we set x equal to 0 there. So at x equals 0, y equals a half. So x equals 0, and then a half is right about there. Kind of hard to see there. Here we go. We'll just go ahead and put a little bit of a red dot there. Maybe like that. There we go. Whoa. No, it's not what we want. There we go. Okay, so there is our y-intercept. Cool. So that means the graph then is going to come down and cross into that y-intercept. So it's going to come down like this. There we go. And then once it gets here, it's going to cross through there going this way. And then there's going to be a hole there. A hole where? Well, at our hole, which is x equals 2. So at here's 0, here's x equals 1, here's x equals 2. So right here is going to be a hole. And it's not going to be a closed hole, so we need to erase that, right? What is it going to be? Yeah, right there at x equals 2 is going to be an open hole, okay? So we'll go ahead and put an open hole right there, like this. And so if you plug it into your graph there, and you choose an x equals 2 value, you're going to get 2 minus 2, which is 0, and that's undefined at that point. So if you graph this, put this whole graph here into your graphing calculator, and then push y, and then push second calc and value, you're going to see that there's going to be a hole right there. And I just need to get the graphing software. Darn, it's on my laptop, but it's not on this computer at home. So I need to. Else I could just show you the graph, right? But just definitely ask me in class, and hopefully you have a graphing calculator. Okay, so excellent. So then we're going to go also this way. So this is coming down to the right. And so what's also coming down was from here coming down. So we're going to go ahead and come down here like this, like that, with an arrow. And then also coming this way, just basically following that asymptote without actually crossing it. If you want to be exact with values, that'd be a good idea, like 1, 2, 3. At 3 or maybe 4, at negative 4, what would this be? Well, that'd be negative 6 over negative 4 squared is 16. 16 minus 4 is 12. So negative 6 over 12 is a negative half. So we'd go negative 1, 2, 3, 4, and then down negative a half. So really it's even closer than that. It even follows pretty close and then comes down. Cool. Excellent there. So there's our graph. So all we need to do now is the domain and range, and then we're done there with this particular problem. Nice. Excelente. Connect those together going down. Okay, so the domain and range, let's take a look at that. So it looks like the domain x values is going to come down, and then once it hits here, we're going to have a problem as well as hitting at -2. So we're going to go ahead and for the domain, we're going to say all, well really you could say x is in the set of all real numbers except what? Except x cannot equal -2 because of the asymptote and +2 because of the whole. Okay, so there's that right there. Make sure you put a line through the equal sign like this. And then we're going to do the same thing, but this time we're going to do it for the y values, right? Because range is y values. So let's go ahead and change that to y. Y is in the set of all real numbers, except that y cannot equal what? What do you think? That's right, y can't equal the other asymptote, which is 0. There we go. Another way you're used to writing it is -infinity to 0, and then comma, and then 0 to +infinity with parentheses around it. Cool, so there is number 3. Then let's jump over to number 5, I believe, that also has a hole in it. I'm trying to see here, number 5 has a hole in it, so we wanted to look at that one. These ones are kind of weird, so hopefully I can show you those in class. Number 5 has a hole in it, and let's see where that hole is. Ooh, so where the x plus 1's cancel out, right? Whoa, this is crazy. So let's go ahead and write it again by going like this. Go ahead and write it on your paper and write it again. So we get y equals x over x plus 1. And then watch this. Watch what cancels out. This is kind of crazy. So it turns out the x plus 1's cancel, leaving us with just x. What do you mean just x, Mr. Newbold? I mean y is just equal to x. Wow! Isn't that just a line? That is just a line. Let's see what that line is in a moment. But this makes a hole, doesn't it? Not an asymptote. This makes a hole because it canceled out. And so where's our hole going to be at? Well, x plus 1, where is that going to equal 0 is the question. Where is x plus 1 going to equal 0? Well, if you have a -1 here, -1 plus +1 is 0. So, or if you just -1 to both sides, you end up with x equaling -1 is where our hole's at. So remember that. Cool. Now, this is a line, y equals x. So, well, everywhere we plug in a 1, we get a 1 back for y. Plug in a 2 for x, 2 back for y. Plug in a 3 for x, get 3 back for y. So this is going to be a straight line, right? Yeah, it's going to be a straight line with a hole in it. Okay. And so what we'll do here, let's see, what should we use there? What do we use for line? Probably this one. We're going to go both directions. And, ooh, let's see where that hole is again, at x equals -1. So we know that at x equals -1, there's going to be a hole there. So here's our line. Again, our if we put in a 0 for x, we get a 0 for y, so there's the origin. Put in a 1 for x, we get a 1 for y. Put in a 2 for x, we get a 2 for y. Okay, so there we go. So the arrow in this particular graph is going like this. Then at x equals -1, we have a hole. We're just graphing this line that's simplified y equals x. So we have a hole there, and then we'll just continue that on. At -2, it's -2. At x equals -3, y equals -3. At x equals -4, y equals -4. So there is our graph. Pretty done, pretty easy, pretty fast for number 5. There's going to be one like this on the test, so that's good to know and see there. Okay, so then what we'll do is we'll go ahead and put in a hole there. Let's try using this one. I've never really used this before. Cool. Yeah, look at that hole right there. Sick. Okay, so we have a hole at x equals -1. Not an asymptote, we have a hole. And do you see any asymptotes anywhere? Maybe, let's see. It goes on forever, below and above. It's just a line, isn't it? It doesn't really curve and approach a number with an asymptote. So, but how we'd figure that out is look at the vertical asymptote. What makes 0 defined in the bottom? Well, only -1, and that was a hole. So, yeah, so there's not going to be no vertical asymptote, right? Crazy. What about horizontal asymptote? Well, let's see here. X squared is what that originally was. And what was that originally? That was x squared plus x, I believe, like that. So if we multiply that x through, we get x times x is x squared. So we'll put a little square there. I'm kind of actually going backwards in this equation is what I'm doing there. And so there we go. So let's put that there. So we have a little bit smaller there. So x squared plus x. There you go. So x times x is x squared. X times 1 is just x. So that's the original problem. And look at this. The power x squared over x to the first power is what that is right there. That's x to the first power. So for a horizontal asymptote, what we'd say is since the top power, highest power, since the top highest power is less than bottom, then we have no. So we have none. No asymptote. That's crazy, huh? Yeah. And so there we go. And if you graph that, you'll see that in the graph using your graphing calculator. So both none and none there, right? And just to make sure, let me show you the rules there that we had for Nancy in case you missed when we did this. So right here is where we talk about those rules with Nancy. What's up, Nancy? So if the top degree is greater than the bottom degree, then we don't have a horizontal asymptote. If they equal each other, then it's the asymptote is right there, 1/3. And then if the top degree is less than the bottom degree, like x to the first over x squared, then it's going to be just 0. Just y equals 0 is your horizontal asymptote. So 0, the number if they're the same power, and then none. Cool. So we'll go back to number 5. There is where we were at. Finish it off here with the domain and range. Excellent. Ooh, the x-intercept, we can tell where it crosses, and the y-intercept. It both crosses at 0. So x-intercept, we're going to put 0, 0. And then for the y-intercept, we're also going to put at the origin 0, 0. Okay, so that's done. That's pretty fast and easy there. X equals 0, y equals 0. Cool. And then the domain and range. What's the domain and range? Well, the domain is every value except for at x equals -1. So you can say all real numbers except for -1, or let's do it this way this time. We could say -infinity, comma, -1, close parenthesis, in union with -1 to positive infinity. And then we'll go ahead and take our number 8 there like this. And we'll go ahead and rotate that 8 to make it turn into an infinity sign. And then we'll go ahead and copy and paste that there. So -infinity to positive infinity. Now the range is, remember the range is going the opposite direction now. The range is going this way. Doot, 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 doot. So we have all values, and then, skip over that. All values for y values. -4, 3, 2, -1 doesn't work, so we're going to jump over it and then carry on there. So then our y values is also at -1 this way though, down here. So it's going to be the same exact thing there. There we go. Domain and range is done as well. Excellent. Okay, there we go. So then we've got -infinity, positive infinity, not including -1, but y equals -1. And then the domain is x equals -1. Cool, so there is our answer there for number 5. So hopefully those have helped you today, and you can ask more questions in class. And make sure we did that right there, looking good right there. Yep, x isn't in the element of all real numbers, is in the element of all real numbers, but doesn't include -1 or -1, none, none. Whole at -1, -1, good. Looking good there, simplest form. Alright, excellent. Thank you for paying attention. And don't forget that Tigger's your friend too. Woo! Alright. Whoa. Boom, boom. He's pretty strong, isn't he? Tempting. Alright, thanks very much, and you have a good night, and we'll see you on Tuesday or whatever day I see you next. Thanks for watching. You take care. Bye for now.